All right, let's get started on Unit 3. So first, we're going to go ahead and, oops, I'm not in my Notability. Hold on. There we go. First, this should say Unit 3 note packet. So if we go ahead and start 3.1 functions. So this is all going to be about functions again. Some of this you're going to know, and there's going to be more that you don't know. So you need to make sure that you are focusing it and taking really good notes and writing things down when I talk through it. Okay. So a function, first we'll talk about the word relation. It's a correspondence between two sets where an input is paired with an output. It can be represented by a table, a graph, a set of ordered pairs, or a diagram. So there's an input and an output, like an X and a Y. Domain, the domain, you guys know it's all possible X values. So the domain is your X values. The range is going to be your possible Y values. A function is when each input is paired with exactly only one output. So that means each X has only one output arrow. Okay, function notation, definitely something you've seen. F of X does not mean F times F. F of X is its own special notation. Pretty much F of X means Y. So sometimes people like to replace F of X with Y. It is the output. The X is the input, the part that you're putting into the function, whatever number or whatever variable it is. And then the output is what happens when you put that number, the input in. So if we take a look at a function rule, it's different for each one. So again, the f of x is your output, or you can call that y, and the x is the input. So you input a number like 2, 2 plus 5 would be 7. The output would be 7. Or it could be a quadratic if you look in the second example where it's a of s. So it just depends what it is. Make sure that if the input here s, if you have more than one s's in the expression, you need to put the input in more than one spot then. So make sure you put it in, for this case, for the function a of s, all of the s's. And then once you put it in, your output would be what it equals. So determine whether something is a function. The big one that people use, you guys have seen, is the vertical line test. That means it only crosses through the graph once. So that's a visual way of looking at it. So if this is your x and your y axis, and you have, let's say, a quadratic that, let me do it in a different color so it accentuates it. If this is your graph, this is a function, because that's what the question is, determine whether it's a function, as long as it passes the vertical line test. So when you draw a vertical line, does it only cross at one spot? Yes. And no matter where you draw that vertical line, it will only cross the function at one spot. So that would be a function. But let's say you have a graph and it looks like this, a sideways view. This is not a function, because now when you draw your vertical line, notice that it can cross the graph at two spots. So that would be a no. It is not a function though. So that's a visual way of determining. You can look at a diagram. Again, each input must be mapped to only one output. So that means there should only be one arrow leaving the X value. The Y value can have more than one, but the X value can only have one arrow leaving it. Same thing kind of when you're looking at a table or a set of ordered pairs. You can only have one of the X's. And then an equation you can also look at, and we'll talk about that. So first, we're going to go ahead and decide, given a table and not even using numbers, is it a function? The problem here is if you take a look at Amy and Carlos, notice that there's two arrows leaving. from the x values. So this is not a function. So you really want to concentrate on the x values. Notice in the second one, every single x value, all of the names have one arrow leaving it. So yes, it is a function. It does not matter if it doubles up on the y values. What you care about is there's only one arrow leaving the x values to be a function. So that's looking at a table. Now let's go ahead and look at an equation to determine if it is a function or not. So we're going to go ahead and determine whether these equations make a function. So we're going to solve them for y. So in this case, when you solve for y, you'd have to take the square root of both sides. And we talked about when you take the square root of both sides, you have to have the plus minus value of it. When that happens, and you plug in a number for x here, you would get two answers. So whatever you plug in, let's say you plug in, x is literally doesn't matter. Let's say we tried x equals 4. When you plug that in for the input, 2 times 4 plus 8, 2 times 4 is 8, 8 plus 8 is 16, the square root of 16 is plus minus 4. Well, you get two answers there. So when x is 4, and if you think about that visually, when x is 4, y could be positive 4, or y could be negative 4. That would not pass the vertical line test. So because mainly, and you don't have to draw a picture, I just was trying to accentuate why, because the y equals a plus minus answer, this is not a function. So when you see that occur, you're going to have two values for y, so that cannot happen. It can only have one value for y. So that x value would have two arrows leaving it. Can't do it. No, not a function. If we take a look at the next one, let's say you tried a number like x equals 4, and if you do y equals 4 squared minus 2, you're going to get y is 16 minus 2, which is 14. You get one y value, which is what you want. So this is a yes. It is a function. So if you get one y value, it's a yes. If you get more than one y value, it is a no. So that's looking at it with equations. Now we're going to look at it with points. So remember, for every x, there should be one y. So if we take a look at all of the x's, there's 1x, 0.2, 4, and 5.2. All the x's have their own numbers. So it is a function because all x's go to one y. None of the x's were repeated. But we'll show you an example where it's not. So this next one, notice we have 10 and it goes to 4, and then we have another 10 over here and it goes to 2. So that's two arrows from the same number leaving it. So again, you should only have, for one x, you should have one y. So the input, so this is not a function because the input 10 has two outputs and we should only have one output, or has two y's. There's lots of different ways to say the same thing. All right, computing the following. So these are definitely things that you have done before. I'm going to do a little bit of it, and then you're going to do a little bit of it. So obviously plugging in a number. So if we plug in f of 1, you're plugging 1 in wherever there is an x. So that's going to be -1 plus 4, which is going to give us 3. That's my answer. If we plug in a variable, you should be able to plug in a variable. So that would give us -t plus 4. And you can put arrows or parentheses around your input if you want, but it's not going to change it. That simplifies to just -t plus 4. And sometimes you're going to get an expression when you plug in a variable. Next one, we're plugging in -x. So f of -x, you're replacing x with -x. So notice that there was already a negative sign there. So you have to keep that negative sign in the front. So there was that extra negative sign in the front that does not, just disappear. Sometimes I see people just put 1, but the thing is there's 2, and because there's 2 negatives, now it becomes positive. So that's a positive x plus 4. You do need to simplify it always. You might be plugging in more than one thing. So for this next one, we're plugging in 2x minus 3. So I'm replacing the x with 2x minus 3. And then I have to add 4 to it. So you have to simplify. That's going to give me negative 2x plus 3 because I have to distribute my negative sign. And then I'm going to add 3 plus 4, and that gives me negative 2x plus 7. That is my simplified answer. Now we're going to go ahead and simplify some numbers here. So part A, g of 2. I would go ahead and I would plug 2 in for wherever there is an x. Since it's in more than one spot, you have to plug it in for both. So 3 minus 2 over 4 times 2 plus 1. That's going to give us 1 over 4 times 2 is 8. 8 plus 1 is 9. 1/9. If you put a decimal, it has to be 0.3 with a repeated sign. If you just put 0.33 or 0.333, you're going to be marked wrong. Or 0.111, sorry, 1/9 is 111. But I would just keep everything as a fraction. All right, I'm going to have you stop, and I'm going to have you try number or letter B here with your input -3, and then type your answer in. All right, so let's go ahead and see if you've got the right answer. So you should be plugging in -3. So 3 minus -3 divided by 4 times -3 plus 1. The numerator, you have a calculator, but 3 minus -3 is a positive 6. 4 times -3 is -12, plus 1 is -11, and that is simplified. Doesn't really matter where your negative sign is. If you have it on the top, that's fine too, but it's -6 over 11. We're going to skip C because I'm pretty sure we've got the hang of it. Let's go ahead and try number 4. It says solve the equation for y in terms of x and replace y with the notation f of x and then find f of 13. So it says solve the equation for y. So let's start with just that and then we'll interpret the rest. So to solve it for y, I would have to subtract x. And then I would have to divide everything by 3. So that's going to be y equals -1/3 x plus 10/3. And it says replace y with the notation f of x. So we're going to replace y with f of x. So the equation doesn't change, just the y. We're changing the format to a function format, a function notation. So that's part of the answer. That's our function notation. Now it says find f of 13. So the second step is to go ahead and find f of 13. So we're going to plug in 13 for x and solve. You have a calculator. Again, I would keep it as a fraction. I would type math fraction on your calculator if you need to. So let me go ahead and type this in and I'll show you what I mean. So here's my calculator. I typed it in. Oh, never mind. It's a nice number. But if you needed to, you could press math and the top option is a fraction, enter. Obviously, this is not a fraction, so it's not going to turn it into 1. But if it was a decimal, you could turn it in that way. Math, enter, enter. So our answer for this one is -1. All right, let's take a look at the last page for the notes here, a little bit more on domain and range. So you guys have been doing domain and range all through Algebra 2. We did it in the beginning and it carries through the entire year. Depending on the type of equation, the domain and the range changes. A linear function, a straight line, the domain and range for that is going to be -infinity until -infinity for both because it goes all the way from the left to the right and all the way from the bottom to the top for the range. Polynomials where the highest degree is even. So those would be problems like x to the 4th, or x squared and x to the fourth, x to the sixth, etc. The domain is going to be negative infinity to infinity, because that could be like a U shape. Think about left to right, it's negative infinity to infinity. But the range, the lowest to the highest, is going to change because there's typically a bottom of the U. Look at, there's a bottom. It does not go to negative infinity, or there's a top part to it if the U is upside down. So the range, you have to look at the problem and do some work. Polynomials where it's an odd degree, so like x cubed, x to the fifth, x to the seventh, etc. The domain and range are both going to be negative infinity to infinity. And those graphs look something like this, but notice they go from left to right, they're going to continue. And from the bottom to the top, they're going to continue. There's no like maximum or minimum value there. Square root functions. Remember, the problem with square roots is you can't have a negative in there. That's an imaginary number. So graphs like this are kind of like a check mark. I always told my students it kind of looks like the square root. It's like a check mark. The domain is going to be, you're going to set the inside values inside the square root greater than or equal to 0. You're going to be doing that all year. That's important. And then the range kind of depends on the problem, but it's going to go when there's not a shift. We talked about shifts in Algebra 2. It would go from 0, but we'll take a look at that. And that's because the range from lowest to highest, notice there's a low point. There's a point that stops here. There's a lowest point. Or if it's reversed, there's a highest point. And then rational functions, these are rational functions. They have a fraction. That's what a rational function is. And there's an x in the numerator in the denominator. You have to set the denominator because you can't have 0. The reason for this rule is you cannot have 0 in the denominator because, you know, when you have slope, a number over 0, and if you type it in your calculator, 5 divided by 0, it'll give you an error. It says can't divide by 0. It's undefined. So you would have to set the denominator equal to 0, not equal to 0, and solve for x. And we'd have to kind of look at the problem to see what the range is, okay? But the two things I highlighted are very, very important. You need to know these two boxes. This happens a lot because those are the ones that actually require some work. So let's take a look. We're going to do different examples on all of them. These ones are just asking for the domain right now, okay? So we're focusing in on the domain, which is your x values. The first one is a linear line, y equals 2x minus 1. You can go straight to the answer, which was, you know, when we were looking up here, linear functions, the domain is negative infinity until infinity. You can plug in any number for x here. So negative infinity until infinity. For part B, this is a square root. So you want to go to the example that looks like a square root. That's this one right here. It says all x values such that the inside is greater than or equal to 0. Again, that's because it can't be negative in there. So that's why it's an inequality. So we're going to say 14 minus 2x is greater than or equal to 0, and you solve. So you would subtract 14 from both sides. That would give you negative 14. You would divide by negative 2. And when you divide by a negative number, you have to flip your sign. So your domain are all values where x is less than or equal to positive 7. And it doesn't tell you what form it has to be in. It says find the domain of each function, so that would be fine. Sometimes, it might ask you to graph the domain. So we know that the domain is from 7 and x is less than it, so it goes to the left. We also could do interval notation, which is from negative infinity, that's the smallest value, up until 7 with a bracket. We reviewed that already this year. So it kind of depends if they ask for interval notation or inequality. So this is an inequality. This is an interval. So depending on what it asks for the form, I'm going to put both just so that we practice both. Okay, the next one, notice it's fractional. So where are we going to look? So if this is the problem here, notice that it matches this section here. And it says set denominator not equal to 0 and solve for x. So that's what we're going to do. We're focusing in on the denominator. Set it not equal to 0, because again, you can't have 0 in the denominator. So what value when we plug it in gives you 0? I would solve this by factoring, okay? I would take out an x. There's a greatest common factor of an x, which leaves us with x squared minus 4. And I would continue to factor. The next part is a difference of squares. So this would be x minus 2 times x plus 2 does not equal 0. And then using the zero product property, I would set each parenthesis, each factor equal to the 0. So x can't equal 0 is one answer. From our next factor, x cannot equal positive 2. And then from our next factor, x cannot equal negative 2. And that should be an easier problem. The factoring there is not difficult. But if you were struggling with factoring before, this makes this problem a lot harder to do. So what does that look like? 1, you could just list those. X is not equal to 0, 2, or negative 2. That means it's everything else. If we looked at what an inequality would look like, here's 0, here's 2, here's negative 2. The graph of this one would be open, 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 and it's everything else in between. It just cannot be those numbers. So it's everything else but those numbers. So at those numbers, I put open dots. Interval notation. Interval notation is the lowest number. Notice this goes to negative infinity. That's the lowest. So negative infinity, and then it goes till negative 2. And then you're going to put a parenthesis because it doesn't include negative 2. Union, the next spot is right here. That goes from negative 2 to 0. And then we've got this next spot here, union, from 0 to 2. And we still have another spot over here. And so then we've got a union to infinity. Notice it's all parentheses because those are all open dots. So that would be the interval answer. All right, let's take a look at one more. There's something very interesting about part D here. It has a radical, so there's a square root in the denominator. So it really falls under both of these. Notice there's a square root and it's rational. So a couple things are going on. So we kind of have to combine the two rules. So the one rule that you take the inside and set it. The one rule is you take the inside, this part here, and you set it greater than or equal to 0. But the other rule is the denominator cannot equal 0. So if we put those together, if it has to be greater than or equal to 0, but it can't be 0, it ends up just being greater than 0. So what you're going to solve is 3x plus 1 has to be greater than 0, and that's because the inequality or the square root is in the denominator. So you would solve that by subtracting 1 to both sides and then dividing by 3 to both sides. Okay, so the problem that I'm going to have you go ahead and try for me is please find the domain of, and maybe I'll put it in a different color here. What is the domain of the square root of 2x minus 6? So I'm going to stop, have you solve that one, and all right, welcome back. Let's go ahead and see if you got the right answer. So you need to set the denominator, 2x minus 6, greater than or equal to 0. So you should be adding 6. And then you should be dividing by 2. So x is greater than or equal to 2. And we're going to go ahead and just keep it in that answer. But if you wanted to, interval would be from 2 to infinity with a bracket. All right, thanks guys. See you later.